Aqua places a high emphasis on safety across our organization. Safety protocol for our laboratory personnel includes a chemical hygiene plan, safety training, and requirements for appropriate eyewear, clothing, and footwear. The Inorganic Chemistry Laboratory is our largest lab with the most staffing. In this lab, drinking water is tested for appearance, taste, and safety, while wastewater is tested to ensure it's cleaner than the rivers and streams we return it to. Using highly sensitive analytical instruments, a variety of tests are performed to identify minerals and metals that can impact water quality, public health, and the environment. These instruments enable us to measure very precisely in parts per million and parts per billion. For some perspective, 1 part per million is equivalent to 1 cup of water in a swimming pool. The instruments use either the wavelength of light, electrical signal, or mass to measure compounds. Each instrument is designed to test for a specific set of compounds. For drinking water, we test for the presence of minerals like calcium, sodium, potassium, and chloride, which might affect the appearance and taste of the water, while metals such as lead, arsenic, and mercury could impact its level of safety. Instruments like the titrator analyze pH, alkalinity, hardness, and chlorine. This ensures water tastes good, is free of pathogens, and doesn't corrode household plumbing. This instrument is a mass spectrometer. It's one of the most expensive in Aqua's environmental laboratory and is used to detect metals like lead, copper, and arsenic that can be harmful to human beings at a high concentration. In wastewater, we test for the presence of bacteria and nutrients by measuring chemical oxygen demand, a monitor of water treatment plant efficiency. It indicates we're doing a good job of removing chemicals such as carbon, nitrogen, and phosphorus that may have an environmental impact. We also test biochemical oxygen demand, a measure of the amount of organic matter contained in a water sample. This indicates if the water we are returning to streams and rivers contains adequate oxygen to support aquatic life. This is an ion chromatograph. It's used to analyze water and wastewater samples for the presence of compounds such as fluoride, chloride, sulfate, and nitrate. Unsafe levels of certain ions can cause conditions like blue baby syndrome, diarrhea, dehydration, and more. Thanks to these state-of-the-art instruments and the experienced chemists who operate them, we can be confident that our water and wastewater supply are being closely monitored for safety to protect and provide Earth's most essential resource for today and tomorrow.